Good. All right. Hi, everyone. My name is Eric Sarro. I'm the software product manager over at Kontron Canada, and I'm here today to talk to you about the SYMKLOUD product and basically the offering that we have and our journey to powered by OpenStack. So Konu, right, Kontron. We have a presence worldwide in 12 countries with production facilities in Germany, Toulon in France, San Diego, and Montreal and Beijing. The team here today for Kontron Communications Business Unit with the booth right behind there is based out of Montreal, so we're proudly Canadian. Our flagship product, what is it? The SYMKLOUD, the MS-29 platform. MS stands for a multi-server. 29 means the first letter is a 2U form factor with 9 compute sleds in it. So what you can see on a picture above here is that we have modular hot swappable top-of-rack switches. These can do 1, 10, 40, and 100 gig capabilities. We have two of those for redundancy purposes, of course. We also have 5 hot swappable fan in the front of the chassis. The system is able to sustain full load even if one fan is out for maintenance. And we also have a customizable faceplate for you to put your logo if need be. And this is actually the biggest use case we have. Most of our customers, you do not know us by the name of Kontron. You usually know us by the name of somebody else, but it's actually our product. So the back of the chassis, what does it look like? We have, again, the 2U form factor. We have redundant 1500 watts power supplies, which basically is able to cater to most requirements and also make sure that we remain in an efficient footprint. Those 9 compute sleds can hold up to 18 independent servers. So what that means is that in a 2U form factor, you can have the equivalent of 18U worth of compute in the same platform. As displayed below with the 8060 sleds that we have, which is 2 single Xeon D processors from Intel. And we're basically able to cater to all types of workload. What you can see on the first line, we have the 8040s, which you can use half height, half length PCIe devices, whether it's GPUs from NVIDIA, FPGAs, SmartNICs, or your own proprietary cards. We're also able to fit in there, not only with the M2 boot device, we're also able to add in 2 times 2.5 inch devices in here to act for a small Ceph node or other requirements that requires more storage. We also have the 8050 sleds, that is our flagship in the media vertical, and basically this has the Intel E315 78 V5 processors, and those are catered more to video transcoding to do 1080p or 4K streams. Mileage may vary on your transcoder software, obviously. So on the 8060 front, what we have is basically the 8040. Well, we took 2 of those, but since we have the footprint, we fit 2 of those on that card. What allows you is that you're basically able to get compute to run high-density workers for Kubernetes or VMs or bare metal when it comes to OpenStack. So some of the applications that we've tested in the past 12 months, we have validated and certified Canonical OpenStack, Wind River Titanium Cloud, Red Hat OpenStack, and as well as in the progress of getting the YES program completed for SUSE. We also have Canonical's Kubernetes distribution available on the platform. Open daylight deployment tools, including Canonical Mass. If you preach the Ansible church, then that works with that too. On the monitoring front, we do have Nagios available as an option, but we're a big fan of Prometheus as well. On the GPU side, TensorFlow, we have 2 demos running on that. We have 1 demo running on TensorFlow at the booth, which is basically to identify properly cats in pictures, so Ildiko is gonna like that. And we also have a use case with the Intel Media, formerly known as the Intel Media SDK, or now the Intel Media Server Studio, which is aligned to the 8050 sleds, and basically anything that has to do with low-profile PCIe cards, including SmartNICs and FPGA. And we've also validated the platform for any DPDK-enabled application or anything that's based like P4 offloading on the network side. So, replacing commodity off the shelf with the MS-29. What does that mean? So you can look on your left, basically what your traditional data center rack looks like. The challenge is that most data centers out there, they don't have 10, 15, 25 kilowatts of power to put in a single 48U. So it's not rare to walk in a data center and look at a bunch of racks, and basically all you see is 5 or 6 systems, and then it keeps going on because they don't just have the juice to power that amount of power, right? So what we did with the platform and making sure that we're highly efficient, we're actually able to replace 36 1U units with 2 of our systems, which accounts to 4U, and those includes the top of rack switches. So it's all about high density, higher efficiency when it comes to racking those systems because the switches are embedded in there. There's a decent CapEx saving not to be neglected at that point, but really it's on the OpEx that we shine through, where power efficiency, this is where we rule, as well as the consolidation of the footprint. And on top of that, we have a bunch of automation tools that removes the burden of deploying the systems and the applications along with the platform. So here's a validated ecosystem that we've built in the past 18 months around the platform. So on the networking side, there's the usual suspects. You can all read, so I'm not going to go through them. Including on the infrastructure and orchestration side, we have a bunch of partners such as Canonical here today for the platform. And we also have a bunch of projects that are really piquing our interest. So obviously Akrano is going to be very interesting to see how it goes forward along with ONAP, but we also have a keen interest in Danos, PNDA, as well as Prometheus. Edge, everybody talks about it, nobody knows really what it is, right? So depending on who you're going to talk this week to, you're always going to get a different answer. The difference is we're actually working with the folks that are deploying actual edge solution near the cell sites and the radio towers. So within 6 months, we went from design requirements to an actual box that can be seen right now at our booth, and that is ready to be shipped soon. So what that means is service providers and telco proof of concepts, we're already there. And we've also did a webinar over at Light Reading with Tigera as well as Verizon, which basically illustrated the previous slide of replacing those 36 systems from a competitor, which is meant to run commodity off-the-shelf system, with 2 of our platform. And the underlying point was those systems cannot run at the edge because they're not power efficient. They don't deliver the use case that needs to be there to be able to run SDN and NFV and edge use cases at that place. So this is where our platform shines. So the link is here. Feel free to go see it. It's quite interesting. But it wouldn't be an OpenStack Summit without community involvements, right? So about 2 years ago, we were about hardware, and hardware. And now we're at a point where we're actually contributing back to the communities. So we've actually contributed a bunch of fixes on the Rally projects, which were committed and accepted by the community, as well as some fixes on the canonical charms when it came to Neutron and Silometer to do a few enhancements on that front. And there's also this brand new edge computing group that's been led by Beth Cohen from Verizon. And basically, out of the Dublin PTG, we've provided some insight based out of the actual feedback that we got from customers around the globe around the edge use case to make sure that the platform and the project is aimed toward solving a problem, and not just a specific vertical, but the entire edge use case across the globe. A new OpenStack Summit means a new OpenStack version, so we're proud to announce that now we fully support Queen in our platform. So what this means is that you have a fully redundant infrastructure along with fully redundant software. So we follow the OpenStack Foundation guidelines of having the tree controllers and 2 Neutron nodes in order to make sure that you're able to do maintenances on the control and the data plane independently without a problem, even in case of hardware failure, which happens rarely on ours, to be honest. So what we have also is work with 6Win. They basically have a product called the Virtual Accelerator. What this does is bring the DPDK capabilities into the platform, but without breaking the Neutron API. So what that allows customers to do is actually leverage OpenStack to its fullest capabilities without having to deal with any shenanigans that SRIOV or PCI pass-through would make happen. We also have the bare metal project, which is ironic, to support any use cases that are based out of GPUs, FPGA, or anything that's going to come out of PCIe cards in the coming years. And of course, we have the deployment scripts and the automation to make sure that it's about removing the burden of getting the hardware configured and just consuming it from the get-go. So that's really the target that we wanted to accomplish, not just ship hardware and wish you good luck, but send you the hardware, have the proper documentation, the script, and the installation process, so that then you're able to go and consume your infrastructure within hours instead of days. So looking back at those commodity servers, and for anyone that is willing to come and chat to me at our booth, I will gladly give you all the data here. Those are not marketing slides. Those are actually built on data that is available for anyone on public websites based on list pricing of the platforms, as well as power consumption, numbers driven by the US Institution for Power and Energy and Efficiency for pricing and defining all those costs. But basically on power consumption, this is where we thrive compared to your typical Xeon Scalable and AMD EPYC systems, and as well as rack space use, because if you go in a model where you're in co-location, space is important. And lastly, on the total cost of ownership. Some might think that our product looks more expensive because the case is shiny. But when you look at the entire picture, you factor in the hardware, the power consumption, the space that it's taking, along with the time that it takes to deploy the platform, we're able to rival with commodity servers, and we leave in the rear view mirror most of the public clouds out there, because public clouds are very expensive. Moving on to Kubernetes. So with the journey we took with Canonical, Mass, and Juju, that basically allowed us to roll out first deployment of Canonical Kubernetes in about 10 minutes. So that was something that was quite interesting to achieve. But then again, we wanted to keep the same model where a redundant infrastructure, a redundant piece of software. We actually are in the works to commit a fix on the HE proxy instance that ensures that all the masters are up and running. So what we did is a tweak on that front so that there's an HA proxy running on every single instance, so that in that front, if you end up pulling out a sled, you don't lose the master cluster. And again, the same platform is available with the deployment scripts, the automation, and the documentation that we provide to customers. So when we're looking at container density, one key thing to understand is that it's not just about containers. There's two types of containers. There are virtual machine containers, which to me are not real containers, and there's bare metal containers. Those are much more closer to the DNA of what containers are meant to be. What that means is that you get rid of the virtualization overhead. So lower network latency, better access to PCIe devices such as GPU, and let's be honest, that's one of the thriving use cases there are for containers right now. And basically the ability to get rid of full-fledged OS when you're looking at serverless and unikernels is going to get a lot closer to that logic down the road. But in terms of guidelines, if you look at the networking limitation, when it comes to Kubernetes, a master can only have a C-type subnet. So basically the amount that we're able to instantiate in terms of containers in that platform in just a 2U system is more than 3,000 instances. But realistically, closer to a VM container type of platform, what you'd be looking at is closer to 300 to 500 instances within a 2U system. So if you have really built your application around microservices, this is a real big powerhouse that you can have within a 2U unit. So we do have two use cases that we have around Kubernetes at our booth. The first one is the TensorFlow and NVIDIA demo. Basically what we have is that we're running image recognition out of cat pictures, as I said earlier, but we also have a blockchain demo which basically illustrate how to use idle processor time to go and do crypto mining in this case. It's Ethereum, it's not Bitcoin, so don't go crazy. But ultimately, we've shown how to leverage idle processor time to do something else with Kubernetes. But also Kubernetes has still a way to the telco's heart. There's a few use cases where if you look at it, it was built by Google. They did a tremendous job, but when you try to take those requirements and bring that in the actual field, there's a few things missing. Carrying over MAC address is one of the key things that's currently missing. There's some SDN and NFV use cases that are still pending. However, we do have one of our employees, Mohammed, which is working actively with Ericsson and Red Hat on that front to contribute back to the Kubernetes project and see how we can remove those pain points. So a few announcements. We've joined the Linux Foundation as a silver member back in January 2018. So we are part of this new networking umbrella. So basically this allows us to be more involved, and we want to show that we're not just a hardware company that's trying to slap a bunch of logos. We're actually actively invested on that front. We also joined the Metro Ethernet Forum to get closer to the Mac/mobile edge computing use case on that front. And on the OPNFV side, we're announcing right now that we're going to be opening a Faris Lab environment in our very own data centers, Montreal, Quebec. And one of the main differences is that access to Faris Lab is very hard to get. And what we wanted to make sure is that not only people can try our platform, but also they could just go and try their application and with the NFV test suite. So you can go to symklcloud.com/opnfv-pharos. I apologize, the URL will be fixed with the hyperlink. But basically there you just put out your name, we're going to contact you very shortly, and we're going to give you access to our systems. The service is insanely popular right now, so there might be a backlog to get access, but please rest assured we're making sure that everyone is going to be able to get there. So, I'm not the only one talking at the OpenStack Summit. We have our very own Valentin Boucher from the Kontron Communications that is going to be talking in literally an hour in level 2, room 208. He's going to basically show you how to use OPNFV to make sure that your OpenStack distribution deployment is fully functional and respond to the test suites that are in Fraser. He's going to be joined with folks from Orange, so please do not miss that. It's a really, really good session. Also, I'll be having a joint interview with Arturo at the Cube, which will be made available throughout the remaining of the summit and also on YouTube. So to complete, we're right behind the Ubuntu booth. We have awesome hardware. There's t-shirts, because it wouldn't be an OpenStack Summit without t-shirts. We have a prize drawing every day. We have Queens going on for a demo. We have a bunch of Kubernetes demo going on. So just come over. The lunch boxes are there also in case you didn't find them yet. So thank you for your attention and have an awesome summit. Thanks.